Good afternoon and welcome to the ASA webinar, 5G Evolution, Security Controls and Assurance, with guest speaker, Dr. David Soldani, who is the adjunct professor at University of New South Wales. My name is Susanna Paloma and I'm the event and sponsorship manager for ASA and will be hosting the session today. Also assisting me today is Julip Sanji from the Sydney branch. Before we begin, I just wanted to go over some housekeeping. David will talk for about 40 minutes. All attendees are encouraged to submit their questions during the presentation via the Q&A button, which is located at the bottom of your screen. At the end of the presentation, we will answer as many questions as time allows. This session is being recorded and the recording will be made available on our website within 14 days. Thank you for your attention and I'll pass on to David, who will start the session. Thanks, David.
Thank you so much for having me today. And I have prepared a presentation on the 5G evolution, but I will pay particular attention to the security controls and assurance. And I will also illustrate the path to 6G. So maybe just a couple of words about me, since most probably I haven't had yet a chance to meet people attending this webinar. So I've been active in the ICT industry for more than 25 years now, and my areas of expertise are especially on future wireless network, cybersecurity, artificial intelligence, IoT and multimedia technologies. And I have been contributing both as an industry player at Nokia 15 years, Huawei 10 years, and in particular serving as a CTO and CSO within the Asia Pacific region, but also as an academic. And I'm currently a adjunct professor at the University of New South Wales. In addition to this, I'm also contributing to the Singapore government, as I am the chairman of the Infomedia Development Authority 5G Task Force. Right, so just to be on the same page, I'd like to present you the global 5G landscape, and this slide shows the current assigned spectrum for the 5G. So you will see here that we have access to spectrum now to 38 plus markets, and more than 128 operators have received spectrum. In particular, you can see here the allocated bands. So we have low band, mid band, high band. Here you have the frequency ranges, and in particular, I'd like you to pay attention to the fact that we have around 100 operators operating in the C band. So we are around 3 to 5 gigahertz, and that is basically the band at which the 5G is and will be, say, mostly deployed. Here, you may also see the live and planned 5G launches. You have many places where 5G is already on. Australia is among those, and you have more than 110 operators that have planned to launch those services globally. Looking a little bit more into the details to get the feelings of what we're talking about here is statistics are coming from the GSMA and GSA, which are the largest global association of operators, so carriers and vendors. So we may see by the end last year, we had already 234 million connections, so potentially terminals connected through the 5G system, and we are expecting a jump in less than 5 years to connect 1.8 billion people, which is pretty much around 20% of the global populations. If we explore the numbers, particularly interesting is the Chinese market, and here you can see that out of the 234 million connections, currently we have a 202 million connections in China, and 822 millions of those out of the 1.8 billions will be still in China. So those are the absolute numbers, and China is definitely the largest market with the largest global investments. And we are having about 210 billions investments by 2025 in this particular technologies. But I'd like to say that the in percentage, so looking at the relative adoption, so we will have that 90% of the 5G mobile connections, looking at the forecast by 2025, will be especially in North America, Europe, and Asia Pacific. So North America is in particular, we will assist to about, say, 50% of the penetration. In addition to this, what we have currently available are really a large number of commercial terminals. So we have more than 400 commercial available devices. And you may see here the different type of form factors. Of course, the majority on this pie chart, we have the smartphones and the fixed wireless access customer premises equipment, which is nothing else than the modem you put it at home for having access to the 5G connectivity. But beyond this, we have many other type of form factors. We have like 34 industry enterprise routers, gateways available, more around 30 hotspots, laptops that are capable of accessing directly to 5G beyond Wi-Fi, tablets, and also we have more than 30 other type of devices, which include drones and robotic platform already commercially available, supporting access to 5G communication service. Now, taking a look at the roadmap to understand where we are and where we will be in 5 to 10 years from now. So 5G was in its release 15, was completely finalized by September 2019 in all its configurations. That means in its non-standalone architecture as well as in its standalone architecture. Release 16 and the first version does support and enhances the mobile broadband experience. The release 16 was finalized last year, and it includes the support to other important usage scenarios, such as the ultra reliable low latency communication services. So both releases, they fully meet the ITU requirements and therefore define the 5th generations of mobile communication system. Now, looking beyond that, as we speak, we are currently specifying, so currently means in 3GPP, the release 17, and the release 17 looks into other type of use case. Then, if we look forward beyond that, we will start looking into new use case category, and then finally we will start the specification of 6G in terms of study items and work item, and the 6G is expected to be launched, deployed massively in the field in about 10 years from now. Okay, now just quickly having a look at the supported functionality and understand a little bit more about the architecture before we enter into the security controls and assurance schemes. We have that the fundamental difference between the 4G, so the LTE system, compared to the new radio, so 5G or new radio, NR, is that the NR basically support all spectra. So that means spectrum from 400 megahertz up to 52.6 gigahertz within the release 15. So from the very beginning and release 16. And then now we are discussing to enhance the wireless interface to accommodate communications up to 71 gigahertz. whereas the LTE has been designed to operate into the sub 3 gigahertz. Okay, there are cases in Philippines that are pushing that up to the 3.5, so in the C-band, but it's properly not designed. So the wireless interface is not being designed for that. That's why we want to have the new radio that is forward compatible in that sense. So here you have a number of features. We don't have time now to examine all of them, but just to mention a few, that is that we have that the massive MIMO, so the possibility of beamforming and beam tracking is available from the launch of these technologies. So it's a default configuration. We do support network slicing. Then the system will be enhanced to meet the requirements of the industrial IoT, that's the Release 16. As I said, completely finalized. We're expecting commercial product later this year, beginning next year. And here we have the possibility to support the unlicensed spectrum, the positioning down to 3 meters. Okay, we have an element also integrated access back only. We have full communication between vehicles and vehicle to infrastructure and roadside unit. And it also is the technology, the future railway mobile communication system. So that means it is the technology that will replace the GSMR. As we know, GSMR will retire by 2030, and we do have now started a massive adoption deployment of the 5G, because the 5G release 16 and 17 will define the future railway mobile communication system. So in the release 17, what we have is a special focus and attention to features that will support critical IoT. Position is reduced to 30 centimeters because we really want to command, control unmanned vehicles in general. And the unmanned aerial vehicles is one of the system that will be supported by 5G, including multi-access edge computing will be integrated finally with a 5G system. We do have also the possibility to access the services not only through cellular, but also through non-terrestrial networks. And in particular, we will have communication in terms of access, not back only, but access as well, using GEO and LEO satellites. I'm coming back to those because we want to make characteristics of 6G later. Okay, then we now go into the security elements. So security 5G release 15 really defines the infrastructure, the basic infrastructure, and the security baseline is then announced further for as the we releases thinking of security controls to meet the requirements of the different services supported. So how the system comes into the picture and how will that evolve? So this is basically the LT system. We have the Evolved Packet Core that connects a number of base stations, denoted a long-term evolution. So that's LT, nothing else. So that's defined in 3GPP as an option 1. We then come into its fast evolution. We may have 2 paths. Usually what we have here is we tend to install the new radio, so the new base station, which is pretty much collocated with the LT and connected to the Evolved Packet Core. The communication goes into the secondary barrier split that carries on the data plane, all the anchoring points, signaling, and therefore the security, the control mechanisms that pass through the LT system. So that's basically the path mostly followed globally, but there are exceptional cases, by the way, including China, or operator that may decide to have an overlay system to their current 4G system to adopt and launch. By the way, this is one of the key steps in Singapore as well, to consider the 5G in its standalone configuration, which means a fresh system end-to-end with the new radio base station connected with the 5G core. And finally, refarm the system so that all the frequency, not only the services, will go to the 5G, and ultimately all configuration will converge to the option 2, which is a standalone configuration on a new radio. And if you started from, say, adding a base station adjacent to your LT system, you have a possibility of combining the option 3x, that this option, the option here, with an option 2 and fuse them and have a possibility of supporting both category of terminals for them refarming your system to ultimately achieve a one system, a one network on 5G. So 3GPP specifies a lot of details, allow the split of the base station into a central unit and a distributed unit. I mean, this thinking behind has a number of advantages, but also some drawbacks. So looking at the advantages, especially in the low traffic area, we have then the possibility of aggregating and sharing the resources over a large deployment scenario. This is particularly valuable as a configuration in the rural areas or for the integration or actually providing connectivity to massive IoT type of traffic. When the capacity increases, so there's a demand of reducing the latencies, then the CU has to go close. Actually, it is co-located with the distributed unit. As of today, most of the deployments are co-located. So that means we do have a box which may either support both technology or multi-technology from 2G, 3G, 4G, and 5G, or you do have a couple of boxes. One is on the LTE support, the other one is at the 5G. They are co-located, so you have a one site where hosts both boxes. Yeah, there are also additional enhancement in terms of architecture, which means for us in terms of security, more exposure, say, to potential external attacks. To GPP specify an integrated access and backhauling, which means that we have the possibility of using the same type of radio interface, the one used for access, also to provide backhaul services to a number of nodes connected to a donor. Yeah, the network slices, those are coming on release 15, and it is further enhanced, including the RAN slicing in later releases, in particular release 17. But I think slicing really could be, the benefit of slices could be especially, or the CUDU split would be especially viable if we have net to slice. So in this particular case, if I have the possibility of chaining multiple slices instances and chain different function, even in terms of CUDU split, then I have a possibility of orchestrating the different virtual function end to end. And on a single physical infrastructure, I have the possibility of even meeting the demand and the different performance requirements coming from a number of sectors or services such as voice critical connectivity, enhancing the mobile broadband experience up to 8K, or even thinking of massive connectivity of millions of connections per square kilometer. So by moving this up and down virtual functions, I can accommodate nicely all the requirements on a single physical infrastructure using slicing and the capability of disaggregating the RAN function. Yeah, a word on ORAN. So the ORAN Alliance compared to the 3GPP, ORAN Alliance introduces additional interfaces, functional splits, and disaggregations. In particular, comes along not only the support of the already specified 5G interfaces, so E1 within the CU and F1 between the CU and the U. They come along with new functionalities such as the non-real-time radio intelligent controller and the near real-time intelligent controller with the addition of functionality as well as open interfaces. And here you have a comparison, more information behind this slide can be found through this link. But in practice, you may see here a number of many more interfaces. So interfaces between the CUDU, but also coming along with this additional functionality for optimizing or improving the performance of the network, which in theory expand the threat and attack surface of the network. I'm coming to that in a second. Now, entering into the chapter of security, control, and assurance, I'd like to start from a rapid review of the most important requirements we are receiving from the industry. So the first set of requirements is in terms of availability of the communication comes from the vertical sector. So it's an important requirement because if you think of connecting machines, cars, vehicles, whether it is a sort of autonomous vehicle that uses services from the network, or it is a teleoperated machine, which is actually the most viable use case identified so far. We need to make sure that the system and the connectivity is truly available, because if you're losing the connectivity or have a problem to communicate through 5G users using here your smartphone, okay, I can reestablish the communication. But one thing, if I'm losing control of a car or a vehicle, so yeah, in this case, we need to make sure that we have a 5.9 or even more reliability. The other set of requirements comes from the carriers. So our telecom service providers, the current focus is on 4 key requirements. So the first one are concerned coming with the introduction of the multi-access edge computing, which is nothing else a way of bringing the application close to the edge. Edge means the base station, so anything that is around me, an end user. So there are some concern because this proxy server capabilities, they define an edge between the core network, so the edge function of the operators and enterprise network, including third-party applications. So there are several concerns of potential intrusions. Slicing, as I said, it is a virtual network that composes end-to-end. So they're concerned whether the communication is truly encrypted, if the risk of evasion or say lack of isolation between different types of slices is truly mitigated. And the other thing is about the fact that 5G is expected to connect more than 1 million devices per square kilometer. So that there's a concern that the denial of service attacks could be really creating problems to the system. And finally, what we are expecting is a system that makes it very easy for operators to orchestrate security and have a way to automate the way to detect and respond to any type of attack, and integrate the usage of artificial intelligence, especially for monitoring. Yeah, just quickly on other concern now coming. I've taken this for a few of the recent publications. You may read it more. There are on the disaggregations of RAN, or the radio access network. So the Open RAN, here you have some of the concerns you may find in this document, and I've just made up just a synopsis of it. So there is a strong demand of security assurance standards, because when you open the software, there are many interfaces that are exposed third party, the possibility of installing any kind of applications here on top of the near real-time RAN intelligent controller. You do have the support of AI algorithm with all the potential vulnerability they may have. And then, of course, you have additional issue on the communication channels, and of course, the virtualization itself, especially using containers where the risk of evasions is really a fact. Yeah, the other requirements we're having now extremely hot, and that where I'd like you to pay particular attention is into having in place globally trusted and mutually recognized security assurance schemes. As you know, now we are especially using common criteria, which are extremely important way of attaining even certificates, but there is not really a clear focus or a clear way or clear security assurance scheme for the mobile communication system. And the mobile communication system is now the security assurance of mobile communication system is now achieved with the close collaboration between the three GPP that are responsible defining the test cases and security assurance specifications, and the GSMA that define the evaluation methodology, and the collaboration between these two organizations has finally come out with an important and currently broadly adopted security evaluation scheme, which I'm detailing now in the next slide. So this is really important. We need to have that as a fundamental input also towards the certification scheme. So we got a question offline about the exposure to radio frequency electromagnetic, so the electromagnetic fields at the radio frequency, so the range of 100 kilohertz up to 300 gigahertz. So I've just made a slide to illuminate and finally say kill any kind of conspiracy behind that, although I haven't heard much about this because it's now crystal clear what has come out from the International Commission on Non-Ionizing Radiation Protections, that an extensive study for many years that found that there is no evidence that the radiation within these ranges of frequency may lead to cancer or any other deteriorating, say, effect on our body. But the only effect we found after extensive study and investigation and epidemiological analysis, we found just a heating of our skin, especially, and some nerve stimulations. Therefore, they have output now some basic restrictions considering the variation in temperature in our body and the corresponding quantity we need to stay below, so that we may avoid these risks and the different, say, requirements depending where you are professionally exposed, which means you're under control, so you may bear even higher level, or you are simply a residential player, household, and therefore the limits are lower. So the conclusions are that basically that the 5G will not have a negative effect on people health, also because you see the radiation elements. I've just made a summary of typical base station configurations you may find now in the field in terms of blade antenna, where you have the split of a passive antenna which integrates all a generation system transmitting, say, in the sub 3 gigahertz. And the upper part, it is the new radio, the 5G, they may radiate at the different frequencies. So that is an example of the C band. And here you have examples of millimeter wave. So the part transmitted is practically very well directed to the end user thanks to the beamforming. So you avoid leakages or anything that could, say, illuminate personnel sitting or passing through below antennas, or even working or living under these antennas. So there is basically no relevant radiations below this particular type of antenna. So you have three kinds of antenna currently. So the one operating the C band, the one at the millimeter wave, yeah, you have the corresponding power at the antenna feeders, and or it could be like a small pico radio remote unit, so the Pico base station here that still uses beamforming, and the power is really on the order of hundreds of minima. So very, very, very low power transmission. So no worries, all good. If you consider a radar, for example, me coming from the military Navy, I was an officer. When we were measuring this, we have a radar in the band Charlie. It was even having a 1 megawatt peak power. So no worries, so good. Yeah. Let's go back to the 5G now. Security is the topic here. So how does the 5G enhances the already extremely secure 4G system? Here you have just an example of those. So we have a much better protection at the radio interface. We do have an integrity protection in addition to the encryption of both plane, user plane and the control plane. We do have the possibility of concealing, so hiding the end user identity, whether it is an identity coming from an end user that uses a SIM card, or is coming from known to GPP type of access. So the end user identity is concealed since the very access to the network. So the privacy is always preserved. We have the possibility of setting policy at the very, very, very granular level, even the flow component. I'm not thinking of the slices, but at the flow. So each flow that crosses the communication system, we have a unified way of authenticating, authorizing, and accounting for the end user. This is the first time in history that the 5GC will allow us really truly converged access to the services, to the 5G services, and it unifies us the way we provide the security communication. We also encrypt the communication between the hosting, so the visited, and the home public land network. Yeah, since people are interested, want to know more, I've borrowed and improved a slide from my friend Rainer Stufholt, which I invite you, by the way, to watch. I place here a link to his one of his recent presentations. So that's basically, it is the key generation hierarchy in 5G. I think it's the most robust and advanced way of providing, say, a confidentiality, integrity, and the availability of the end-to-end communication services and information. It's all based. We could spend one day on this slide just to capture how it works and why it's so secure, so robust. So the posture is really excellent in that sense. So it's all based on a shared key secret, which it is stored in the core network and into the end user device, and based on this shared secret, absolutely secret, hard-coded into the SIM card end users and stored into the core network. So here you have the authentication server function, but it could be also found in the repository. Practically, it is stored and archived into the repository functions. Then it is propagated through the network, and out based on this shared key, we derive all the keys across the different part of the network, whether the network, it is the home network, the serving network, or the domain of the radio access network. We use the one key, and then we derive all the other keys that will allow us to achieve integrity of the communication, in this case through the wireless interface here, as well as the encryption of both the user plane and control plane. Maybe a couple of things to remember. We do have a symmetric authentication. That means as the network authenticates, the home network, not the visitor, home network authenticates always. The end user constantly refreshes and asks, who are you? Who are you? And so just to make sure the communication reaches out the intended person. At the same time, we also have the possibility for the term authenticating the network. So route base station or an attempt, as it was back at the 2G system, of getting this device camping and connecting to a false network is simply impossible. Beyond this, maybe one word. Now we also have the introduction of the AKAMA, which is a authentication and key management for the applications. Those are all the applications on top of the 5G can be truly authenticated. This is particularly valuable for the Internet of Things. Okay, then beyond the end-to-end system, maybe a couple of words about the remaining part of the interfaces, which are also protected end-to-end. As you know, the 5G system is a service-based oriented architecture, so pretty much follows the protocols of the internet. I'm thinking of the HTTP 2, for example, which is now adopted. It makes use of the internet secure protocols and procedure and controls for achieving authentication, encryption of data, integrity, and authorizations. So you may see here, although the system is decomposed, we still have the possibility of protecting various interfaces using the IPsec. And then towards the core network, we have the TSL and IPsec could be also used. And within the core network, we have the possibility of encrypting the data and provide authorization using Auth 2.0, which are all protocols perfectly working, coming from either, say, 3GPP through the announcements or from the Internet task force. Yeah, what happened next then? So as the 3GPP release 15 really defines the posture, the security infrastructure, the architecture, and the baseline in terms of protocol for security controls, but also assurance. So it presents the mechanism and the test cases in order for the vendor as well as the operator, but also authority, verify that certain mechanisms are supported. The following releases further enhance all those, say, security domains, from security assurance to the security architecture. Also, they introduce measures for security for vertical, so here network slicing. I will show you some of the security control in a moment. They protect vehicle-to-X communication. AKAMA already introduced you to protect the applications end-to-end. What else we have here? Yeah, then with release 17, we are also thinking of enhancing the encryption key, so the famous secret, so which now 128 bits. We are thinking now to double in its size. So the release 17 will be, will have especially in focus the IoT, the Mac coming also in release 17 with crystal clear security mechanisms in terms of authentication, authorization, accounting, the communications between the applications installed into the Mac and the end user. Of course, security enhancements will be also across the all domains in terms of integrity protection, authentications, and false element identifications. Important, as I said earlier, is the network equipment security assurance scheme, which is a scheme, as I said, that targets and solves the problem of having mechanisms for security assurance for mobile communication systems. And this is achieved with GSMA and 2GPP collaborations in terms of the NE-SAS schemes. Here you have the links where you have more information, but in short, what we're having now available, already used, but we have the main vendors already complying to the auditing process, and some of them meeting the even the test cases for the equipment security evaluation. So the scheme consists of two main parts. We do have specification on how to achieve and assess audit the product creation, so the product development and the life cycle processes, or how those products are made and maintained across the entire life cycle. So we do have a clear auditing methodology that comes out then at the end with an audit report. And we do also have in place a methodology for evaluating the security of each network element. So we do have for the base stations as well as requirements and test cases for the core network, and the process run by third-party independent and authoritative organization leads to test reports. The first release of NISAS was already available more than a year ago. We are now further enhancing, and we will soon have access to the NISAS 2.0. As we speak, this scheme is under discussions and promoted, particularly in Europe, but also globally. For example, I'm thinking of Singapore here in Asia Pacific region, and I hope also in Australia we will have this kind of conversation. So we have the BSI in Germany that advocates for the adoption of the NISAS within their certifications strategy, and it is of February the 3rd that the European Commission mandated the ENISA to draft the new candidate cybersecurity certification scheme for the Union, adopting the NISAS. Yeah, just to show a little bit how we may mitigate some of the concern I mentioned at the beginning. Although, as I said, the concern we're having with the 5G, they are pretty much what we're in place for 4G. And as of today, for 5G, there is no attack vector. So there's a lot of theory, but no practical attack vectors. There are no incidents currently in the field. And but still, here are the mechanisms addressing exactly this problem to avoid the issue that may arise, for example, in the core network. So in the core network, we are introducing mechanisms targeting to hardening the model, so avoiding any potential attack through the different type of interfaces. And we introduce a hierarchical way of isolating the kernels, the most important part of the core network. In addition to this, we have a way to introduce redundancy, diversity, providing an elastic scaling of the system, or even say a solution using pooling of the same type of function, so that we are introducing resiliency that would allow us to respond to any kind of attack. Looking at the different planes, we are introducing, we have introduced actually the 3-plane isolations, just to avoid that any issue potentially coming into the user plane may affect the control plane and vice versa. And also the management plane, we have a completed system design that isolates the 3 distinct domains, from physical ports down to using different type of tunnels with a direct communication between the peer entities, secure, reliable, and not interfering or say introducing any degree of dependency from the other domains. Slicing, even here, we would need an hour to explain all the details, but slicing is now completely with the 3GPP release 16, completely the security control for slicing completely specified and implemented in the system. So we have 3 fundamental mechanisms deployed in the system, we will start from protected tenants. So the ones that will access the virtual system so they can compose their network. So we have anti-tampering mechanisms using the PKI, and then we have a way of handling the rights and the domain-based management, and approach using the TSL and the authentication with OAuth 2.0. Then looking at the slice itself end to end, we have a double protection. So we protect the slice itself using different type of keys in primary authentications. And then when we think of the mobile phone accessing an intranet, like smart grid, in this case, we are also supporting a secondary authentication as the internet in general works, which is compatible and supported by 3GPP with the extensible authentication protocol. We use different keys, and we also cipher the network slice selection assistant information, which is a one identifier for this slice that you establish end to end. Of course, we may also introduce access control in terms of firewall, virtual firewall, and network encryption using IPsec, as I presented you earlier, across the different interfaces, not necessarily under the control of 3GPP or specification 3GPP. And then, beyond that, to prevent resource abuse, we introduce isolation, especially at the physical layer, but also at virtual layer in terms of whether we use virtual machine or containers. Finally, what it is required to have in place, it is a security operations center, and that's pretty much what our operators or the telecom service provider have in place. And these are generic platforms, but you may have four main components. Let's quickly review them. You do need to have a platform that allows you to manage security, which goes to the provisioning of the keys, certificates, identity, and so forth. You need to have a way to easily, instantaneously, in real time, analyze what happened into the various parts of the network, not only interfaces, but also within your virtual and physical infrastructure. That is done with the head of security agents. And native agents are the best, as the one making the equipment has a clear understanding of what it's all about, where to capture information and report. So that's necessary for having the possibility of immediately, in real time, detecting what happened into your network. An example, signaling storms, denial or distributed denial service attacks, or attacks that may happen to the OEM plane that are well beyond what could be in place into your data and security control functions. And then we need to have a platform for security control, which is about a system that allows you to define your policy, orchestrate your policy with even supporting automatic response to potential threats, and therefore instantaneously, or say in time, block any potential attack or attempt to attack, and even recover from adverse situation. Security, how do we achieve really security resiliency end to end? And in practice, it requires an effort of 5 distinct organizations. We tend to push to all the requirements to vendors, but it is not enough. So we need to have an agreement and collaboration between these 5 parties. So we're expecting, and the vendor must ensure to come out with a trustworthy products, which means practically to support all the standard specification, additional security control mechanisms I presented you earlier. But beyond that, what is even more important, there are the operators that they are responsible for the overall network resilience and operation security. Beyond that, when we use the application, we need to make sure that our end-to-end service is really secure, encrypted, and authentic. And this is the responsibility of the application service provider. I'm thinking of, in particular, of the web scale type of organization. And last but not least, we need to have a constant evolution of the standard specification security assurance scheme, thinking of 3GPP, SCAS, and NISAS, and the government regulatory agency that need to formulate appropriate role regulatory frameworks and implement an end-to-end supervision program, and in particular, I would say, conformance program, so that all of us understand clearly what we need to meet for achieving a trustworthy system and resilient way of communicating. Now, introducing 6G, why are we now discussing this? We're not far, because we have a couple of more years of research, and then we will start specifying this system. So what's the vision behind the next generation of information and communication technologies? This is my vision, is so simple that I believe that all intelligence will be connected with zero trust model through digital twinning. That's going to happen at the edge using 5G, 6G, and in particular also at the edge, we do have a need for the machine reasoning meet the machine learning. So here you have the main trends that justify my conclusions and allowed me to pitch this compelling vision. Yeah, just to give some example here, for example, artificial intelligence has to be used only where it is exactly needed. I've taken this from Roberto Cingolani and Giorgio Metta from the IIT in Italy, where they prove simply that the cost per operation are from 1,000 to 5,000 AI machine than humans to perform exactly the same tasks. In other words, let's say Roberto's son, you give Roberto's son a chocolate, he goes a week, whereas ICAB, which is the most advanced humanoid in the world, it would last only 2 hours. So that means we need to take the brain of these elements and push that to the edge. So that's to go to the cloud. That's the first trend here at the edge, what I'm seeing. And then I'm also justifying the other things that to meet latency, we need to be at the edge. So that means the computation has to be close to the enforcement platform. Then machine learning and many flows. So the machine learning has flows in terms of so many limitations and how it operates, biases. So we need to have another way to represent intelligence that will be through reasoning. We need to absolutely reduce the greenhouse gas emissions in terms of CO2, and to be efficient, we need to digitalize everything. That's why digital twinning. And then the next fundamental shifting paradigm that justify would motivate the 6G. We need to shift from all things connected to connected, trustworthy intelligence. So just a couple of slides of 5G concludes my talk. I'm not sure, Dilip, Suzanne, whether I still have time. I didn't keep the time, but so the vision we're having on the 6G, it is about connecting the physical world with the cyber world, and this connection between these two worlds is possible through different new communication channels. So yeah, I've just mentioned the was mostly important. So the 6G will operate at a very high frequency. We have millimeter wave and terahertz, so that will allow us to really sense the environment. So that means the base station will become a neural edge that will capability of really seeing around anything. I don't know whether you have ever seen a radar, how the radar works. Similar here, we have those capabilities to have a clutter, a return, to learn from the environment. Therefore, the most important channels will be on sensing capabilities and learning, constant, continuous learning. So with a distributed intelligence across the whole system. And then in the downlink, the communications, since we will speak, anything, everything, we speak to a digital world. It's not a matter to communicate to people here. Here it's to communicate to entity intelligent, which means capability of representing knowledge, ability to elaborate this knowledge, and ability to draw conclusions and make decisions. In order to do that we will use the virtual channels in terms of virtual AR, VR in particular, the tactile internet. So this particular haptic feedback will be available through the communication, which is not currently possible with the 5G, as latency would require below 5 milliseconds or even 1 millisecond end-to-end. And then the inferencing means we do have a channel that exchanges specific parameters for the inference platform that will be basically in the end devices. So the network drivers are completely different. So what we think of here is from cloud-centric to AI native, infrastructure, information-centric shifts to a network as a sense, as I mentioned, from a security-centric, so the architecture, the 5G, we want to have a zero trust model since the very beginning, and user-centric instead of a generic pipeline. It has to be prosumer-centric instead of an operator-centric. Prosumer me, I'm not only consuming the services, but I'm the key contributor to generating the service. To give you an idea where we had, you may look at my courses, but what we're introducing here with the 6G is another parallel plane, if you allow me to do that, which is a machine learning pipeline. It has to be further sophisticated by introducing the reasoning systems. But I give you an idea where we will have, in addition to the user plane, control plane, management plane, we will have the machine learning pipeline or a neural system in communication between a various type of entity that will perform intelligent tasks end-to-end. And the concept of machine learning pipeline has been already introduced to the 5G, maybe really 17, not sure, but 18 and beyond will support the distributed machine learning with the possibility of orchestrating the different functions, learning functions end-to-end, starting from an intent, which is a use case I'm targeting to achieve, that we make use of measurements, to the inference platform into the recipient, which means the sink or the particular element into the network, could be the device at the edge or in the cloud, performing that particular task. I'd like to mention...
Sorry to interrupt, David. We really, we're running out of time, and I thought we should at least have one or two questions from the audience. I'm so sorry. I know you talk for hours on this topic.
Yeah, it's a lot of content, and just 2 words. So
yeah, of course.
I'd like to send invite you to read an important paper from ABI Research, which introduces the potential threats and novel events expected on the next generation's information and communication systems. In particular, is threats coming from the many things connected and the possibility of having quantum computers to attempt to break the complex encryption algorithm. I doubt it. I don't buy it, but that's plausible, say this way. And then possible security controls, which will be in place in addition of what we are having designed and adopted for the 5G. In particular, I'd like you to pay attention to the zero trust architecture from the very beginning, and the possibility of having distributed ledger technology such as the blockchain for integrity protection. So I'm concluding this talk today. Really, thank you so much for having me, with a recommendation to adopt, study, and incorporate the NASAS into your certification accreditation processes so that you may achieve a way of defining your security standards for policy definition, security authorization in the country. And if you want to know more, I have included here a number of paper talks and presentation and recordings where you have all the, I think, most of the details I wasn't able to present today. So Susanna, thank you so much. Grazie.
That's okay. Thank you. What we might do as well, a lot of people have been asking if your slides could be made available, and I will send out to everyone that's registered, if you're happy, those links to all those papers and so
yes,
forth.
I've shared with you the PDF.
Yeah, great.
I'm not allowed, or we're not allowed to distribute the changeable, but the PDF, I sent it to you this morning, and
yeah,
I think
great.
I appreciate you can share that.
Yeah, perfect. Not a problem.
To know more. Yeah.
Yeah. Thank you. Thank you so much, David. We really appreciate your time. It's a very informative session. And ASA really appreciates the time you've taken to be with us today. Thank you to all our members for their participation today. As I mentioned in the opening, the recording from this session will be made available on the ASA website within 14 days. And you can find out more information about our upcoming events at asa.org.au. So thank you again, David. Thank you, everyone, for being a part of this today, and all the best. Thank you.
Thank you, David.
Thank you so
very
much.
much. It was a really a great presentation. We learned a lot about